this is about running your Go programs on a Raspberry Pi using a system called gokrazy. In terms of agenda, I'm first going to give an introduction. What is gokrazy really? And to illustrate that, I'm going to show a demo video of what it looks like to first install gokrazy on a Raspberry Pi and how you would add a program to your new installation. Then I'm going to talk about supported hardware and how we can implement fully automated Linux kernel updates. Then, once you know what the system roughly is, I'm going to talk about what you can do with it. What sort of appliances can you build with it? And then afterwards, I'm going to also show you a couple of Go programs that you might have already seen and used, and how you can run them on gokrazy and what that adds to your appliance, or how that can be an appliance in its own right. And lastly, I'm going to end the talk with an outlook on future developments. So what is gokrazy? I've already mentioned it allows you to deploy your Go programs onto a Raspberry Pi. Specifically, it allows you to deploy your Go programs as appliances. What does that mean? The opposite of an appliance is sort of a general purpose computer. You can use it one day to do your web browsing, you use it the next day for spreadsheets, and you use it the other day for watching a video. An appliance, on the other hand, is a device that has only one single purpose. So it's custom built, and typically that also means that you don't want all of that extra stuff that you would then need to maintain and don't really use. You would want to focus on your sole purpose of this particular device. You can build these appliances with gokrazy and run them on a Raspberry Pi or a PC, and I'm going to talk more about that in a little bit. A big feature of gokrazy is that it is 100% written in Go. Specifically, the only non-Go parts that you kind of need to have a modern system running is the Linux kernel, which, as we all know, is written in C. And then there are also a couple of bootloader binary blobs that we have to take from the Raspberry Pi Foundation in order to make the device actually start. You don't need them on a PC, of course, but I wanted to mention them nevertheless. But specifically, when I say that the system is 100% written in Go, that also means that it doesn't run C software. So there is really no C userland on a gokrazy device. There's no glibc, there's no OpenSSL, there are no package managers like apt or DNF or what have you. It's all just Go. And that also means that you can enjoy all of Go's strengths uniformly for the entire system that you're building. So specifically, this means that if you have already used the Go module in your day-to-day life to build software, then you will seamlessly be able to use the system because everything, like all the components, are managed as Go modules. This means that the gokrazy system itself is a Go module, the Linux kernel is in a Go module, the firmware blobs are in a Go module, and so on, right? So that specifically also means that you can modify any part of the system locally by using the replace directive, just like you would in your regular Go development. There are many other advantages of Go, but one advantage that I would like to point out is that Go has very quick compilation times. So it's great for interactive development, and this is no exception in gokrazy. All right, so seeing is believing, and I figured I'd just show you a demo video of what it looks like to install gokrazy on your Raspberry Pi for the first time, and then how to add a program.
Welcome to this quick demonstration of how to first install gokrazy on your Raspberry Pi. I'm going to assume that you have already done the preparation work of installing Go and installing the gokrazy CLI. I have prepared an entirely empty SD card, and we're going to jump straight to step 2 of creating a new gokrazy instance. With the goknew command, we can see that we now have a new instance created, and we can use the gokoverride command to write it to the empty SD card. Now I'm going to insert the SD card into my Raspberry Pi. Now that the Raspberry Pi has started up, we can copy and paste the link that the gokrazy CLI gave us to open up the web interface of gokrazy. Let's add another program to this gokrazy instance. We're going to use the webstat command. And this time, instead of using gokoverride, we're just going to say gokupdate. Now that the device is back, we can reload the web interface And indeed, we see the webstat command has been added, and it should now be available on port 6618. And indeed, we now see the same output in our web browser as on the connected monitor.
All right, so that's what it looks like to do the first installation. I hope you now have a better picture of how to use it. And now let's dive a little bit into what happens behind the scenes. So first, we're going to talk about what is being written to disk when we run the first gok override command. On a gokrazy system, there are 4 different partitions. The first partition is called the boot partition, and it contains the bootloader files. These are the binary blobs from the Raspberry Pi Foundation that I mentioned earlier, or if you're installing for a PC, this would be your EFI system partition. Then you have the root file system. The root file system is present in 2 versions on the device. On your first installation, you'll only have the root A, and then it uses an A-B update scheme to alternatingly update the currently inactive partition as you run your first and next update and so on, right? So it always updates the inactive, reboots into the inactive, and then goes vice versa. The root file system in gokrazy is a read-only compressed squashfs image. And this is important for appliances because in general, in appliances, you want to minimize the state that you have so that whatever storage medium you have in your device will be the most durable. I remember that was an issue in many years ago with bad SD cards in the Raspberry Pi or compact flash storage or what have you. So typically, you want to only read and minimize writes. But obviously, for many appliances, you do actually need to write some data. And for that, you can use the permanent data partition. So you have 100 megabytes for boot, then 2 times 500 for root, and the whole rest of your storage device, like the remaining, 15 gig of your SD card, or the remaining 2 terabytes of your NVMe drive, depending on the system you're running it on, will be available for your own use. Okay, but what happens when you insert the disk into your Raspberry Pi and you start it up? What happens at runtime? The first process that runs is the gokrazy init system. This is what the Linux kernel starts, and the main purpose of the init system is to supervise the installed programs. Supervise here just means that the init system will try to start all of your services, and if they crash, it will restart. Right? It's very simple supervision. This is also the program that displays the web interface that you've just seen in the video. And if you want to, you can also configure it to not only show you the log output of all your programs in that web interface interactively, but also send the logs to a central syslog server for browsing them later and collecting them centrally. Obviously, only if you have enough devices for that to make sense. If you only have 1 Raspberry Pi, maybe that's overkill. This is also the program that provides the network update functionality. So the gok update command that you've seen earlier, that is just talking to the init system. Aside from the init system itself, there are a couple of small programs that gokrazy comes with. For example, the DHCP and the NTP clients. DHCP is required so that your device can obtain an IP address from your local network and connect to the internet. And the NTP client is required because the Raspberry Pi doesn't have a real-time clock that persists across reboots. So every time you boot it up, you actually need to configure the time. So these are sort of the 2 minimum viable things you need to get your device going. Then, for interactive debugging in a default installation, there is a tool called BreakGlass, which is gokrazy's SSH server. The default environment that you get when you log into that SSH server is a BusyBox environment. For those of you who are not familiar, BusyBox is an embedded Linux toolset, meaning that it's typically used on devices that have a small footprint, and it provides you all of the typical tools that you're familiar with, like CD, ls, top, ps, whatever you have, right? All of these BusyBox will have a small version of them. And if you need to run some more advanced software in order to poke around in the system, diagnose some issue that you have, or something else entirely, you can also bring your own software. You can build a static version of strace or tcpdump and then just copy them over interactively into the BreakGlass SSH environment and run them like that. So it's very convenient to debug it, despite not having a traditional C user space on the device. All right, so now that you know roughly what's going on under the covers, where can you actually run the system on? I've already mentioned a couple of times that it runs on the Raspberry Pi, and in fact on the Pi 3, that was the first version of the Raspberry Pi that the project supported, because the Pi 3 was the first 64-bit CPU that was supported by upstream Linux, whereas the older Pis were using a non-64-bit CPU, and those actually needed the Raspberry Pi Linux kernel fork, which is not the same thing as upstream Linux, right? Then once the Pi 4 came out, we added support for the Pi 4, and later the Pi 02W came out, which is a very interesting variant because in regular operation, it draws less than 1 watt of power from the wall, which is great. So you can really run like full Go processes on a device that is very power efficient. I've also mentioned that the gokrazy system can run on standard PCs, and I'm going to talk more about that in a little bit. The example on which we first added PC support is the PC Engine's APU, which is also sort of a small embedded PC, but it actually supports any PC that you have, as long as it's AMD 64. I would guess that with a couple of adjustments, also i386 would work, but I just don't have any i386 machines anymore, so AMD 64 is what's supported. Both the more modern UEFI boot, but also the older MBR boot mode is supported. When I say supported, what that means is that before a new Linux kernel version can enter the gokrazy project, and before any new firmware versions and all that sort of stuff can make it into gokrazy, they are actually tested on a couple of devices that I'm running in a continuous integration setup. And only when they pass all of the tests will that be available. There are actually a couple of community-supported alternatives, which means that they don't have the same level of rigorous testing, but they still work. So for example, some people said that it's nice to have the upstream Linux kernel, but they have older Raspberry Pis, so they just took the Raspberry Pi Linux kernel fork and packaged that for gokrazy, and that works as well. There's even people who have an alternative device to the Raspberry Pi. There is a series of devices which is called Odroid, and those work as well. They require a custom kernel and a couple of other adjustments, but there is a community-supported version of gokrazy for these. All right, this was sort of the base PC that you're running it on, but really the peripherals is where it gets more interesting. And the really big thing here is Wi-Fi. If you have seen me talk about gokrazy before a couple of years ago, it might be worth having another look, because now, since March 2022, we have support for not only unencrypted, but also encrypted Wi-Fi networks. And all you need to do is configure your SSID and your pre-shared key, and off you go. Because the chip is the same on the Raspberry Pi that does the Wi-Fi and the Bluetooth, this also sort of gave us Bluetooth support for free. When I say Bluetooth, however, what I mean is the low-level stuff, Bluetooth low energy, which is useful for querying sensor data from IoT devices and stuff like that. This doesn't mean a full Bluetooth stack, so you can't connect your headset or your wireless keyboards or stuff like that. But, for IoT devices, it's good enough. All right, so I also mentioned that we have automated Linux kernel updates. The goal here is to make new Linux releases available ASAP, so that you don't have all of these annoying security issues in your devices that might actually be connected to the internet, right? So the way it works is we have a whole bunch of automation. We have automation that sort of tries to emulate a manual process. The automation runs every day on a GitHub Actions cron job. It looks for new releases on kernel.org, and if it finds that there is a new Linux version available, it will actually make a modification to the source code telling it, hey, download the kernel from this new URL instead of the old URL, and then it sends that change as a pull request. Sending this pull request triggers another automation run. Now the pull request is taken, and a kernel is built on GitHub Actions, which is actually built reproducibly. So if you don't trust GitHub Actions, you can build it on your own device or somewhere else entirely, and it will be bit for bit identical. Once the kernel has been built, it will amend the pull request with the kernel, and then the update of the pull request triggers another run of automation. This time, the already built kernel will be installed on a couple of sacrificial Raspberry Pis, where if they break, it's no big deal. I'm just going to fix them and unstuck the problem. And if these devices successfully boot with the new image and they pass the on-device test suite successfully, then the pull request gets merged automatically. So you can kind of tell that these are exactly the same steps that you would do as a developer if you were to do this update manually. So it's very easy to sort of see where the process stands and to intervene if something goes wrong. The result of this automation is that we have a track record of having most new Linux kernel versions available in gokrazy within 24 hours after their release. And I think that's mostly because our automation only checks for new versions once a day. Otherwise, it would be even faster. If there are issues, then that means that typically it takes a couple of days for the new version to enter gokrazy. Issues, there can be transient issues of something going wrong on GitHub Actions. Maybe you need to rerun your CI run. But more frequently, at least in the past, there have also been issues where a patch that we had would need to be updated because the Linux kernel source code has changed, so you need to rebase your patches. That requires manual intervention. We have since tried to get rid of most of the patches that we had, so this is a very rare occurrence, and most of the new kernel versions actually get pulled into the system automatically. All right, so now that you roughly know what it is, how it looks and feels, let's talk about what you can build with it, because an operating system is only so useful. Really, it's about the appliances, right? One example that I would like to show is called Conserv. This is for the people who have like a home lab, or maybe they have a small rack at work where they have serial console ports on their servers. Why would you use a serial console in 2023? Well, if you make a configuration change on your server and you reboot it, and suddenly it's no longer available over the network, how are you going to recover it if you're not in front of the machine? The serial console port can be very handy for that. And what Conserv does is it allows you to connect a USB to serial converter to your Raspberry Pi, or multiple, no problem. You can even use a USB hub and then connect multiple USB to serials. And it makes them available over SSH. So that's very easy, very convenient, secure, and you can recover your servers like that. As an additional bonus, you can watch Matt Layer and me start this project on stream. So the original creation of Conserv, you can look at it and see how it is to develop for the system if you're curious. All right, so maybe you don't have a serial port in your home, but what you definitely have is paper mail that you get in your mailbox, right? So are you actually diligently scanning and organizing the paper mail that you get, or are you just throwing it in a big pile because it's too much effort to organize it properly, and then in a couple of years down the road, you're frantically searching through a stack of documents looking for that important invoice or that important policy update or whatever you have? I thought, well, maybe it's time to actually digitize this, right? So I bought a scanner, and because it was pretty cumbersome to use the built-in app that the scanner provider, the scanner vendor provided, I decided I would want a more streamlined solution. So I built ScanToDrive. ScanToDrive is an appliance, based on gokrazy, running on your Raspberry Pi, and this scanner that you see here is connected to that Raspberry Pi. When I push the button on the scanner, the blue button that you can see there, after inserting my paper mail, obviously, the Raspberry Pi will start, and it will do a scan, and then it will convert that scan into a black and white PDF to Conserv file size, and then it will upload that PDF onto Google Drive. This is important because on Google Drive, now you have optical character recognition for free, and that will allow you to have full-text search over all of the documents that you upload that way. So if I need to find my insurance policy update from 5 years ago, it's just 2 words away in my search field. ScanToDrive supports the Fujitsu ScanSnap scanner that you can see on the picture natively, but it now also supports any AirScan compatible device. So if you have a scanner or a printer scanner combination that was marketed as compatible with the iPhone, then you probably have one that works with ScanToDrive right now without any extra drivers or anything like that. All right, and then lastly, to sort of step up the complexity ladder a tiny bit, the last example appliance I want to show is called Router 7. Now, I used to use the OpenWRT software on a Turris Omnia router for a number of years, and it was a great setup until one fateful day in May 2018, when there was an automated update to the Turris Omnia, which brought in a DHCP client that broke my IPv6 connectivity. I can go into more detail later as to why this was hard to fix, if you catch me outside. But eventually I decided, nothing is moving here. I have enough, and I thought it would be fun to build my own router, and it was. So router 7 is actually a Go DHCP client, server, DNS forwarder, like all of the components that you need to build a small home internet router. And because I built it from scratch, I could build it to the goals that I wanted to achieve, which are to maximize connectivity, to be reliable, and to be debuggable. And you're welcome to check out the project website. I'm also going to share the slides later to see a couple of the cool features that allows you to do. As I mentioned before, gokrazy supports running on a PC, and this is the reason why. This whole system was built on a PC Engine's APU, which is the device you see in the top right. And later, when I upgraded my internet connection to 25 gigabits, I needed to move to something beefier. So that's the PC that you see on the bottom right, and that's when we added UEFI support to gokrazy. All right, so these are just a couple of examples. There are more examples also on the gokrazy website. We've seen people build children's toys, monitoring systems, all sort of stuff, anything that you can imagine building in Go and that supports the peripherals that you need to use, if any. You can run it. I run all my home automation with it. It's a great solution. But there's also existing Go software that you don't need to write from scratch, that you can just add to your gokrazy installations, or out of which you can make a personal appliance on their own right. So let me give you a couple of examples for this. One system you might have heard of is Prometheus. It is a monitoring system and time series database, and it's very popular in like the cloud space, Kubernetes, etc. So probably you've come into contact with it, or you will. And it comes in many parts. So one part that you could, for example, install on your gokrazy device is the Prometheus node exporter. This allows exporting metrics, and it allows you to monitor your Pi's CPU usage, the available RAM, the free disk space, all these sorts of basic system statistics. You can also go one step further. You could say, well, I'm not so much interested in what's happening on the Pi itself, but maybe you want to run the black box exporter, and that allows you to probe other targets, for example, on the internet. Maybe you want to check that your company's website still has an SSL certificate that doesn't expire tomorrow. You could do it with the black box exporter. And in the preparation for this talk, I actually checked out of curiosity whether you could run Prometheus itself on gokrazy, and it turns out, yes, you can. But I would recommend, if you wanted to do that, to use good durable storage. Don't use SD cards for your Raspberry Pi, because the write load will probably be too much for your SD cards at least a couple of years in. So better run it on an SSD or something. All right, another cool Go program that you might have heard of is Tailscale. In case you haven't heard of it, they market themselves as a secure network that just works. What this means in more technical terms is that it is a zero-config VPN that uses WireGuard connections in a mesh configuration. So the traffic is going directly between the participants of your VPN and is not going through a central server. By adding Tailscale to your Raspberry Pi, you can make your Pi's services available over Tailscale. So this is super cool, for example, if you have a Conserv installation or a ScanToDrive installation or whatever you have, and you just want to access it while you're on vacation. Just install Tailscale on both of the devices and off you go. I've also checked, when I was preparing this talk, that you can run Tailscale in a subnet router configuration on gokrazy. And this means that you can make your entire local area network available without having to install Tailscale on any of the other devices. So if you want to remotely access your NAS, your PC, your server, your printer, I don't know, whatever you have, right? You can do it with that. Just get a Pi 02W, consumes less than a watt, install Tailscale as a subnet router, and there you go, VPN router done. And lastly, another notable piece of software that you might have heard of is Docker. And there is Podman, which can run Docker containers, which is available as a standalone static build that we have packaged for gokrazy since April 2022. And the reason why this particular software is so important is because it sort of gives you an escape hatch. It allows you to run non-Go programs on a system that is otherwise entirely in Go. So you can use this temporarily or permanently if you want to run something that doesn't really fit into this model, right? And one example I have here is the Ubiquity Unify controller, which I believe is parts Java, parts a couple of components that are obviously not Go. And I ran the Unify controller on a gokrazy device to manage my Wi-Fi access point, and it works. Another sort of more bespoke setup is the IRC chat setup that I still use to this day, where I use the very old IRC program in a screen instance with a couple of Perl scripts. So that's really a blast from the past, but I don't really want to rewrite it in anything else. So I'm just keeping that running in a Docker container based on Debian. It's fine. All right, so now that you know what you can do, either building it yourself or adding powerful existing Go solutions, let me give you an outlook to future developments of where gokrazy is going. One important project that we're working on right now is called GUS, the gokrazy update service. And what you've seen previously in the demo video is a synchronous update. So that means you run the gok update command and you directly update the target device. What GUS allows you to do is to decouple this. It makes it asynchronous. You can then build a new version of gokrazy, upload it to GUS, and whenever the device comes online, it can download the update from GUS. This is important if you have intermittently online devices, but notably, it also allows you to implement one-to-many updates, meaning that as an appliance author, for example, if I were to say, I want to make it easy for people to run my ScanToDrive, I could just build a new image of ScanToDrive, for example, in my GitHub Actions CI, and then upload it to GUS and have many, many people download this new update from GUS. In the same spirit, the other project I want to talk about is the gokrazy image daemon, which is a daemon that allows you to download the same images that you could upload to GUS, but it allows you to customize these images. So if you think about the first installation experience, in particular, if you want to, let's say, hypothetically, you have parents or friends and you want to install a Tailscale subnet router in their home. How do you do it? Well, the most convenient way is probably to drive by and do it for them, right, then and there. But if that's not a possibility, are you really in the mood to walk them through, well, this is how you download like an SD card image, this is how you etch it onto the device, and then you need to start your Pi, and then you connect a monitor, and you connect a keyboard, and you configure your Wi-Fi? No way, right? But with the gokrazy image daemon, you could pre-configure the image so that it automatically joins the Wi-Fi network with the correct credentials. And then all they need to do is insert the SD card into a Pi. You can take this one step further even and use the Tailscale example from earlier. You could even make it so that in the Tailscale admin interface, you could have a download link where you get an image out of that download link that is pre-configured to join your specific tailnet, and it doesn't require any other setup, right? So this is quite a powerful mechanism and really allows for easy distribution of such appliances. All right, this is all I have for you today. There are more information and documentation on gokrazy.org. If you have any questions, talk to me after all of the presentations are over, or catch me anytime at another Go Meetup, send me an email, IM, whatever. I'm also going to share the slides, and I would like to ask you to give me feedback on this presentation, either by clicking the link here or by scanning the QR code on the top right. So with that, we're going to hand it over to Tom for his next talk, and I'm going to say thank you.